Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome back to Reliability Matters. I'm so glad you're here with me today. This is actually take two. All full disclosures, and my apologies to my guest. We started off 2 questions deep, and I realized I hadn't hit the record button. A very rookie mistake. I feel like I owe it to you to confess my digital sins. Dave Trail is my guest today. He's worked for companies including Aegis Industrial Software, Kajiscan, Critical Manufacturing, all with a common theme of connected factories, which brought him to Arch Systems, where Dave is currently Vice President of Sales. Arch Systems, just for background, works with top-tier global manufacturers to extract data from machines and drive uniform metrics for enhanced productivity and predictive analytics. They focus on electronics manufacturing, supply chains, digitizing both greenfield and brownfield technologies. So it's my privilege to once again welcome Dave to the program. Thanks, Dave, for doing this again. A little deja vu here, huh? Our audience won't experience that, but a little deja vu for you and me. So
good to see you again, Mike.
Good to see you again. Yeah, now I have to change my whole script. I have seen, last time I saw you was about 40 seconds ago. One of the things that I read in introducing you was 2 terms that I'd never heard before. And just when I think I've heard everything, at least once or twice, all of a sudden I realize I'm not ready to retire yet because there's still things I don't know. And that is the term greenfield and brownfield factories. They may make perfect sense to many people, much of my audience. I'd never heard of that term before. So help me understand in your world what that means.
Okay. So in my world and in my understanding, greenfield site would pertain to a brand new facility. Let's say a company was doing production in the United States, China, and Europe, but wanted to build a factory in Mexico. And they started from scratch by constructing a building or buying a building and putting brand new equipment and processes within that building. That would be considered a greenfield site. A site that has been in production for a while, that has already existing processes, existing equipment, maybe existing software, that's what we would consider a brownfield site.
So kind of a very industry-specific way of saying new or used, repurposed, exactly, yeah. New or repurposed, yeah.
Trying to be fancy.
And by the way, I should point out to my audience that aloha is the perfect word to greet you today because you live and work from Hawaii, and I am in California. So we are spanning usually I span the Atlantic Ocean when I talk to guests across any ocean. In this case, it's the Pacific. So aloha, Dave.
Thank you, Mike.
I've seen you at conferences in the past. The most recent was the Pan-Pacific Symposium of Microelectronics, produced by SMTA, and that always occurs on one of the Hawaiian islands, usually very early in the year, January or February. I think I saw you there just before all the madness broke out in early 2020. And then you were talking about Industry 4.0. And anytime I see interviews of you, when I did some research, it's always on that same subject of connected factories and digitizing information and things like that. So what brought you into, of all the different segments within the electronic assembly space, what brought you into kind of an expertise in at least selling or marketing or talking about or knowing about Industry 4.0?
Well, expertise is a tough word, but we'll stick with that for now. So in the early mid-90s, I got started in SMT, and that's kind of when pick-and-place equipment started becoming mainstream. They were still using mechanical centering jaws, laser in the head centering, some camera, fiducial controls, etc. And they were very, very slow machines, but they were very, very high tech at the time. I remember trying to explain what I did to some of my friends and family, and it was just kind of, those little green things that go inside electronics. I helped build those, was kind of the explanation. So it was very, very high tech and very somewhat cutting edge. And then over time that evolved, and pick and place became more mainstream. The technology got faster, more accurate, components got smaller. There were changes in things like flux chemistries for solder paste that made things more efficient, went to no clean. Then AOI kind of came on board, and at first that didn't really work. It was just kind of a very expensive conveyor. And then that started to work. And then probably about 10 years ago or so, I was standing around at one of the trade shows and I was looking around, and that particular year, there really wasn't a whole lot of, really granular cutting edge innovation taking place. I mean, there was little improvements that were happening, but kind of everybody could place components on boards. Everybody could solder components. Their reflow ovens, they all worked. And I noticed the equipment was kind of becoming commoditized. And at the time, there was some rumors or some talks about the standard they called it a standard called Industry 4.0 out of Germany. And that was all, kind of new and seemed cutting edge. And I thought it was a good idea to try to stay on the leading edge of technology. And I made a transition from equipment and process into software. And I started working at first with connectivity and then, throughout MES. And now I'm focused particularly on Industry 4.0 and AI and ML for electronics assembly.
Excellent. You work for Arch Systems right now. Tell me a little bit more about the background of Arch Systems. I know it specializes, at least partially, if not entirely, on connectivity. What does Arch Systems do? What type of company are they? What types of products do they offer?
Sure. You mentioned that they focus on connectivity. That was my misconception also when I first started looking at Arch Systems. Connectivity is something that Arch does. However, we wouldn't consider that our product. It's a necessary part of the technology that we utilize in order to deliver our true product, which is advanced analytics, AI-based algorithms, machine learning, and being able to look at the manufacturing process and utilize all of the data from the factory to improve processes and increase efficiencies within the SMT sector.
Excellent. And here's kind of a very ignorant question for you. I've often wondered it, but I've always been too embarrassed to ask. But you and I are friends, so no one's listening. Why do they call it Industry 4.0? Was there a 3.5? Was there a 3.0, a 2.0, a 1.0? The first time I heard about any kind of connected factory, it started with 4. And I'm assuming there was a precursor to it. Are you aware of that? Or
yeah, sure.
Did you all just sit around in a room and go, 4 is a cool number?
Well, it was 4 figures, right?
Exactly.
So no, actually, Industry 1.0 started, at the turn of the century. Industry 2.0 had to do with using machines and things like that. Industry 3.0, which you may be aware of, even though that occurred in the 70s, had to do with using electronic control systems, things like PLCs and some electrical means to drive production and improve the process. That's where you started to see things like computerized manufacturing equipment and things like PLC controls and wiring of systems to perform functions that typically were done, either mechanically or through some very industrial type machines. It's kind of where electronics started to take off. Industry 4.0 is the building upon that, utilizing data and some of the advanced internet technologies that we use today. So Industry 4.0 is actually building upon Industry 3.0 and was originally kind of termed and envisioned by the German government in the 80s. So, in 2013, I think is finally when they released their papers on it, and it kind of started to become a thing. So it got started in Europe.
Oh, okay. Very interesting. I did not know that. So many companies, both Arch Systems, in some of your promotional videos, talk about this 99% goal of optimization. And I hear 99% all the time. We have a 99% safety record. We have a 99% efficiency record. Everyone shoots for 99. And that's really, I think, an awful number. And just to put 99 into perspective, I often look at 99 as 99% as like, that's the goal we want to reach. But if the U.S. airline industry produces over 5,000 flights a day, actually yesterday there was 5,670 flights in the air. Assuming that's not as high as it normally is because we're still recovering from the pandemic. If the airline industry in that particular example had a safety goal of 99%, then how many? 56 of those airplanes would have a safety problem, right? Just 56 of them every day, just based on a 99% safety record. If worldwide the airline industry was satisfied with 99% safety, then over 100 flights a day would be flying unsafely. Who knows what that would come out to? So that, to me, that would be 99 is just a strange number. It's just some comfort number that people have in their head. It really needs to be, if not 100, 99 point and several numbers after that point, after that decimal, right? To account for scale. So, obviously the last 1% is an exceptionally important number when it comes to large scale manufacturing. And in a promotional video that was produced by Arch Systems, they made a statement, but for manufacturers who think they've achieved 99% efficiency just because they've achieved 99% quality, again, there's that 99% number, they're almost always wrong. In fact, your company stated that it doesn't really exist, this 99% efficiency. That's because no one's ever seen a manufacturer actually running anywhere near 99%. And then you suggest the real numbers could be 60% or as low as 10 to 20%. So where does that data come from, and what leads manufacturers to overestimate their efficiencies?
Sure. Yeah, the 99% number is something that I've heard for years. You go into factories and you talk to the plant manager or sometimes the CEO, and they one of the first things to come out of their mouth is, we have 99 or 99.5% quality. What can you do for me to improve that? And there's a lot of companies that do achieve that. It's difficult for some of them to achieve, but 99% is somewhat common within the industry when you're talking about quality. The problem is, and the topic of the paper that you talked about is what's hiding behind that 1%, and what did you sacrifice in order to get that 99% quality? We would argue that in order to achieve 99% quality, the majority of manufacturers have slowed down their efficiencies, their productivities, and the speed in which they run their products, which thus reduces the overall margins and profitability of the company in order to achieve that 99% quality. 99% quality is great, but as you mentioned before, there's a lot of companies that are achieving 30 to 40% efficiency, even world-class companies, some of the best of the best. When we look at their numbers and we start breaking down the efficiencies that they're seeing on their factories, they're less than 50%, almost all of them. And some of them are much, much lower than that. Our goal is to not intrude upon the 99% quality, but also improve the efficiencies and the productivity to a level that approaches 99% as well. The topic is, why not achieve both?
Yeah, that makes sense. There was a statement made that the 99% efficiencies are kind of hiding in plain sight. Sometimes we don't see things that are hiding in plain sight. Engineers tend to, for example, kind of go against Occam's razor theory, where the most obvious answer to what's being presented is the most obvious answer, right? It's the simplest. Mm-hmm. Engineers tend to be very critical thinkers, and they dive deep. They get the shovel out, and they basically shovel out a rabbit hole, and they drop down in it when the problem may be somewhere on the surface. So what types of efficiencies are commonly hiding in plain sight, and what do you think is preventing us from seeing them?
Okay, part of that has to do with, as you mentioned before, engineers are very critical thinkers, and a lot of times their ability to focus on a problem is really what makes them great engineers. However, sometimes you need to have that ability to focus, but you also need to have more of a global view of things, and then be able to focus in particular on areas where you have hypotheses that there may be an issue. a good example that I have on this actually just came across our desk this past couple weeks. We're working with a very large electronics manufacturer in the automotive industry. And they came to us to do a proof of concept. They wanted to see if we were able to connect all of their pick and place equipment and to be able to provide global KPIs and to be able to look at some of the efficiency ratings of this equipment to make sure that they were getting the most out of their equipment that they could. And we did that in a very short amount of time. Within 3 weeks, we were able to demonstrate a good ROI on that project. And in fact, it went so well that they said, all right, so we want to do a stage 2 proof of concept, if you will, and we want you to connect all of the machines in our SMT lines. And that includes the printers all the way through the ovens and test, et cetera. And we did that, and that's something that happened relatively quickly as well. And this manufacturer has plants in China, they have plants in North America, plants in Mexico, and plants in Europe. And we had them all connected. And we were looking at all of the real-time numbers as they were coming in, using various dashboards and using some advanced analytics algorithms to determine, things like uptime, efficiency, et cetera. And what they noticed is in part of their manufacturing process, as a product would come out of pick and place and go into their X-ray machine, the X-ray machine would obviously take a look at some of the bad parts that were on there, and then the operator would double check that and make sure that those parts were in fact bad, or if it was a false call. And in the majority of their plants, they had a staging conveyor right by that semi-automatic process, and the transfer time for each of these machines was 10 seconds. That's what the transfer time from beginning conveyor to end of conveyor was 10 seconds. So that should have been a pretty static number, right? But what they started noticing is in their plant down in Mexico, they were getting a 7% variation in that, meaning it wasn't always 10 seconds. Sometimes it was much more. Sometimes it was a lot less. And they didn't know this, okay? They just noticed that, well, wait a second, we're having a problem here. Maybe we need to cut down the amount of AOI inspections that we're doing, or maybe we need to dumb down the inspection so that we can improve this cycle time on these boards to eliminate this bottlenecking that was occurring. Because obviously you don't want your bottleneck to be in your X-ray machines. You want it to be in your pick and place, obviously, because that's the most expensive part of the line. And as we started looking at this, we noticed that variation. Sometimes it was 10 seconds, sometimes it was 17, sometimes it was 24, and they didn't quite know why. And we started looking closely at that with our data scientists that we have on board at Arch Systems, and their subject matter experts in the SMT area within their factory. Put our heads together, and they actually went down to the plant in Mexico. And as they started looking at the process, they're watching the operators go back and forth, and they noticed that they had an operator that was managing several different lines at a time. And that's pretty common in our industry because a lot of it is so operator unintensive, and most of it just runs. That the process, their standard operating procedure was, at a certain point in time, if the X-ray gave some type of signal, the operator would go over there and do that inspection and make sure that the board was good or bad and have it move on its path. And in all of the other factories, they had a staging conveyor, okay, that would allow these boards to accumulate so the operator could go then and look at those, okay? And in this particular case, because they didn't have that staging conveyor, that X-ray machine became the bottleneck. And that was something that was right in plain sight. And the director of manufacturing that we were talking to, he said, you know what? I actually never noticed that we have staging conveyors at our other factories, but not at this one. So it was a trees through the forest or forest through the trees type approach on this that they simply wouldn't have seen if they didn't have access to the data, looking at all of the processes on the SMT line itself.
Interesting. That is definitely a good example of plain sight. You trip over it practically, and it only becomes obvious once it's pointed out, right? It's just one of those things. So while Industry 4.0 has been in the public consciousness for, I don't know, a decade now, maybe a little bit longer or thereabouts, do you think that the industry as a whole has a real grasp on the full benefits of Industry 4.0? In other words, do we spend more time talking about the technology behind 4.0, protocols, things like that, versus the benefits of 4.0? I hear a lot about the technology, and whether it's CFX or other protocols, whatever. I hear a little bit less. Maybe it's just because I'm a geeky guy and I kind of fall into the technology thing, but I don't hear as much talk about the benefits of it. Is that your perception as well?
Yeah, I think that's something that we've been plagued with as an industry. We've been so focused on, the how of, how am I going to get this data out of my machines? How am I going to get it into a database or into my MES, or what standard should we have to make all of this much easier? And we've spent 4 years now working on a standard that is making it easier, but still there's a lot of equipment that are not using the CFX standard, and it'll actually be many years until all of the equipment does have this standard. And there's been a lot of focus on that. And because of that, there's been a little bit of tunnel vision, and a lot of companies that say, all right, I'm getting the data out of my machines, I'm doing Industry 4.0. And that's not true. I mean, just because you're collecting some consumption information or traceability information and things like that, and you're seeing some very, very basic uptime, downtime KPIs, that's not really Industry 4.0. Industry 4.0 is much larger than that. Is doing all of those things and is using all of those technologies, but it's building upon those, providing all of the efficiencies and production capabilities and profitability and productivity that builds upon these technologies that we've been focused on for, I think, a little bit too long, actually. One of the good things about Arch is, as I mentioned before, we do connectivity. However, that's not necessarily our product. We do that because we have to, okay? We're very, very good at it, but honestly, it would be much easier if a lot of other companies, the equipment vendors just supplied it as opposed to us having to get it. But the fact is, there's not a whole lot out there as far as true connectivity that goes beyond track, trace, and control and traceability and those types of things to be able to harness this type of data. And, Arch as a company provides all of those Industry 4.0 benefits, and we're seeing improvements within our customers to the tune of millions of dollars for 10 cents on the dollar or less in investment, and paying itself off in a few months as opposed to several years.
So you talk about just because a machine collects data, we build cleaning machines, right, to clean circuit assemblies after reflow. They collect a lot of data, and then we make that data available to our customers through either to go in and grab it out of the SQL server or export it on an Excel spreadsheet or whatever. We think we wouldn't say specifically we're 4.0. We're obviously not 4.0. I don't even think they've gotten to cleaners yet. But it seems like we're part of the way there. But it sounds like that's not it at all. I would imagine part of 4.0 is not just collecting and transmitting data. It's probably also receiving data and compensating for the data it's receiving. Am I correct there? They are a conduit for information, both receiving and transmission. Is that right?
Yeah, certainly, what you're doing with your equipment is you're contributing to Industry 4.0, and you're providing an input into Industry 4.0 as a concept or as a goal. However, just providing data isn't in itself Industry 4.0. Industry 4.0 is a much larger view of that by being able to take that data and data from other pieces of equipment, and whether it be, realizing that if you make this change to this machine, it will improve this process later down the line. That's part of Industry 4.0. But being able to take all of the data, digest it, make it useful, and allow it to make the process better, that is the true part of Industry 4.0 that I think a lot more companies are getting close to these days. Several companies are doing it, but there's still quite a few that are still caught in the weeds of worrying about connectivity and things like that, where there's a much bigger fish out there that can be fried.
Yeah, it sounds like it's not just the collection and distribution of data; it's the discernment, interpretation of data that really
Yeah.
makes it all worthwhile. Otherwise, it's just big data, right? We live in a world of big data, and data mining has become an industry in itself, right? There's just so much out there, but just the collection of data in itself is rather trivial, I would guess, right? It's just interesting information.
Yeah, just collecting data for the sake of collecting data doesn't necessarily bring a whole lot of value to anybody, at
Right.
least today. I still believe that people should be collecting as much data as they can. There's a concept out there called dark data. And dark data is truly something that does exist. And what that means is it's data that's being generated, and it can be potentially used at a later date, at a later time. So you should store that data. But just because it's not usable today doesn't mean that it's worthless. It may be usable, in the future, and you can't retroactively, create data. It makes more sense to collect it now.
Yeah.
So all the data that can be collected, the better.
Yeah. Its time has not yet come in that dark data example.
Yeah.
So we talked about, it's a perfect segue. We talked about people thinking they might be Industry 4.0 and they're just really contributors on the sidelines to 4.0. Are there any other common misconceptions about Industry 4.0 that either keep people out of it or keep people resistive to it, or maybe suck people in for the wrong reasons?
Yeah.
From a sales standpoint, I think you're the perfect person to answer this question, right? Because you probably have seen over your career from other sources, obviously, many misrepresentations, whether intentional or accidental, of 4.0.
Yeah, I mean, there's a long list, of those types of misconceptions, and I'll just touch on a couple really easy ones. The first being that data storage is complicated or expensive. Cloud storage of data is very, very inexpensive. We're talking to the tune of, a couple terabytes of information per month, not costing hundreds or thousands of dollars. We're talking tens of dollars per month. So the cost of data storage is not complex, it's not expensive, and it's not difficult. The other misconception is that it's difficult, and that this is a major project that is very overwhelming and very time consuming and very intrusive and obstructive, and it's going to slow you down, and you don't have the time to put into this. One of the things that Arch does that a lot of the other companies that do things similar is we're able to get an entire line or an entire factory connected, not in months or weeks, but in a matter of hours. A good example of that is right at the beginning of the pandemic, we were connecting a plant in China, and this is a pretty big plant. And we were able to connect, I think it was 196 Fuji machines, Fuji pick and place machines, in approximately 10 seconds. It was literally press a button, boom, you're collecting data from all of these pieces of equipment, all brought together, all normalized, all merged with all the other data into the cloud in a fraction of time. And it didn't shut down the lines. It didn't shut down the operators from doing what they were doing. This was all done completely white glove, touch free.
Interesting. Yeah, excellent. So in an interview you gave back in 2017 with my friend and colleague Phil Stoughton on his Scoop TV broadcast, you stated that millennials are slowly gaining entry into management positions, decision-making positions within companies, which I can see that as well. And to paraphrase something you said, which fascinated me, you said that the difference between the older managers and the younger managers is, the older managers are surprised to find out that we can connect these machines together, and the millennials are shocked to find out they're not connected. Right? Yeah. They just expected they would be. So is there a generational gap when it comes to understanding the benefits of Industry 4.0?
Yeah, when I mentioned that, I was a little bit concerned when I watched it, because I didn't want to make it seem like I was calling anybody behind the times or old or too young either. Kind of what I was just talking about was just the frame of thought at the time where, younger people, they grew up with technology. They grew up, with computers and things like that. I'm not that young, but I remember in elementary school using computers versus, my father. He probably didn't use his first computer until 70s or 80s or so. And all of these millennials that are coming on board right now, they're very digitally savvy, and electronics manufacturing, while we're building some very complex, complicated, very, very high tech products, in a certain way, the equipment that's doing this isn't, it really should be connected, is how the millennials see it. Meaning, so this machine is doing all of these things, and what do you mean I can't get the data out of it? I mean, surely there's a screen on there. Surely it's generating data. Um, why can't you? As opposed to some of the people that, once again, this forest through the trees type of thing is, they've been focused on solder paste, wetting and de-wetting and things like that. That they're focused upon the particulars as opposed to the larger view of, sure, that reflow oven. Yes, you need to maintain all these different zone temperatures and ramp cycles and clean or no clean, et cetera, but also there's data being generated in that can be used within the process. So I do think that this the deviation that you're talking about that I mentioned in 2017, I think that is evaporating as people are becoming more and more attuned to what's taking place in the industry. A lot more companies are doing these types of things, and there's a lot of education that's taken place over the years, and these millennials are moving more and more into management and buying decision makers. And the people like you and I that have been around for a while, we're looking at the equipment in the industry maybe a little bit differently than we did, 3 or 4 years ago too.
You mentioned earlier you're a sales and marketing guy, as am I at heart, right? I think all entrepreneurs are sales and marketing guys, right? They're selling themselves, they're selling their passion, their ideas, their dreams, hopes. I do definitely see a difference in the way we market to customers today versus 30 years ago when I started my business. And 30 years ago when I started my business, there was no internet, there was no email. It was you either mail something, and if you really wanted to make an impression, you FedExed something, right? Because that always gets opened, it gets put on the boss's desk. And you ran ads in print magazines. You had bingo cards in the magazines. You circle number 132, and a month later you might get a brochure in the mail. And now, I can't think of the last time we ran a print ad. Even the way we look at trade shows is different. The younger people are I think they enjoy getting their information on their own time, in their own medium, and much less conventional than in the not too distant past. So it's definitely changed the way we market. And, the more experienced people, let's call them, in our industry, who've been around a while, adapt very quickly. They may fight the adoption a little bit, but they do adapt. So I think the millennials are what lead the charge in terms of who we cater to, who we sell to, how we sell to them, and then everyone else kind of catches on, right? And
certainly,
it's not like you pull a switch and you instantly stop marketing the old-fashioned way, but you certainly start graduating toward this, and clearly, I think what will help Industry 4.0 get the last mile, which is always the hardest, the last 1%, to use the analogies we were using before, is having an entire generation of people who expect it, who are shocked more that it's not complete rather than shocked that it is as complete as it is. It's just, they'll pull it toward them rather than us pushing it toward a prior generation. Does that make sense?
For sure. Yeah, exactly. I think, and I wasn't around in the 60s or 70s in the industry, but I think in a lot of ways, those times were the experienced people kind of coaching up the younger people and, teaching them about the industry and taking them under their wing and teaching them certain things. I think that still occurs in a lot of ways, but I think there's also quite a bit of push from the younger people, motivating the more experienced people as well, and opening their eyes to to stuff that, really is, not to use the too technical term, pretty cool,
I agree. I totally agree. I think it's a push pull. It's
Yeah.
the young pool, the older, they help lift them up, to that next plateau, and in many cases, the more experienced help push up the younger. So it's just. I think it's a yin yang kind of thing. I think the industry works because of both, and it's nice to finally. We've talked about this on the show many times before, but it is nice to see kind of a mitigation happening for the silver tsunami. For all the experienced sages finally retiring and moving to your island, and he's like, oh no, and younger people coming in to kind of fill those roles. So I hear the term IIoT, Industrial Internet of Things, and Industry 4.0. Are those synonymous terms, or are they actually quite different from each other?
I wouldn't necessarily call them quite different because they do play in with each other. However, a lot of times they're misused and interchanged in a way that they probably shouldn't be. IIoT has to do and speaks about the connectedness of different devices or systems on a factory floor that are communicating together. Industry 4.0 is the capitalization or the benefit of all of those devices communicating together and adding all of it together to have an output. The way that I would look at that is if you're if you manufacture engines for cars, you are in the automobile industry, but you're not the automobile industry in and of itself. It takes a lot of different players to come together to create the automobile industry. So Industry 4.0 is the utilization of multiple different tools, part of which is IIoT to create the benefit for the user and the companies that are capitalizing upon it.
Yeah, that makes perfect sense. So certain Asian countries have, they're well known to have a labor benefit cost wise, right? That's just the way it is. Not just Asian countries, other countries too, but particularly Asia. Will the efficiencies afforded by Industry 4.0 lead to a situation where North American manufacturers can more readily compete with their Asian and other country counterparts? In other words, can Industry 4.0 lessen the gap in manufacturing costs between countries?
I think so. Many years ago, companies like in Asia were able to utilize, pure low labor costs to be able to attract business and be able to sell or to produce products at less cost than what you might be able to do in Europe or in North America. Over the years, and I've spent a lot of time in Asia over the past few years, and that low labor rate isn't quite, what it was earlier. The middle class in Asia has really gotten quite expensive, and even living in certain parts of Asia are as expensive or more expensive than parts of North America and Europe. And what you're seeing over there is they realize that, and they realize that they're middle class, and their population is evolving, and it's becoming a consumer society just like ours. And they're trying to stay ahead of the curve, and they realize that low labor is not going to carry on forever. And in many ways, they're just as on top of this digitization wave as we are. And because they want to keep their production there, and they realize that it's easier to keep it there than try to attract it back again once they digitize their factories. But yes, to answer your question, I think as companies become more efficient, more productive, they're able to improve their utilizations and the profitabilities of their companies and lower the costs to produce goods. Certainly, I do believe that products will move back to Europe or North America, and I think we're already seeing that today. And we're also seeing that some of the production of certain products that were historically done in China due to these lower labor rates they're moving out of China because the labor rate isn't as economical as it was before. I think we probably face a bigger challenge, not on labor versus labor or product versus product, but it's in supply chain and being able to get the components or the raw materials necessary to build these parts. In this part of the world where there's entire supply chains that have been built up over the past 20 years in Asia that have been sacrificed over here. You're seeing that right now in the semiconductor space. And a lot of countries are really looking at that saying, well, wait a second, we're closing down semiconductor fabs and we need to reinvest, to the tune of billions of dollars to build a new semi-fab in our country because we don't want to have to worry about trying to find it on the other side of the world.
Yeah, same could be said for rare earth minerals and things like that too. We shut down all the mines because we had someone else that could do it cheaper, and then it turns out that someone else is holding too many strategic strings, and we rethink it. Yeah, it's frustrating to know we had it and we let it go, and now it's even more expensive to bring it back again. But I think we learn. Hopefully, what we learn from history is that we don't learn from history. Hopefully that's not the case. Hopefully we can actually learn something from history. I guess in a lights out factory situation, which ultimately the Nirvana case, I don't know if it's really possible, but obviously everyone talks about lights out factory. If we connect everything together and we have enough automation and information flow, we don't need people there. I don't think they mean that quite literally, but we need less people there. In that scenario though, every country is pretty equal because we all pay the same amount of money for the equipment, give or take. Yeah. Maybe real estate could be a little less or more in certain areas, but that's not the driving force. The driving force is all that technology plus people. And as you said, with the gap lowering, the tide raises all boats, and countries that are exploited, I don't mean that in a negative term, but companies that are exploited for their low labor tend to raise the standard of living for the low labor, so it's temporary. It's a temporary exploitation, and then they find another country that's even cheaper, and then that country gets, rises up, and then they go all over the world until every country is got a middle class now, and they have cars, and they took all their money and they built freeways, and people want to drive on them, and they want to wear designer clothes and carry around MacBook Pros and all that stuff, and iPhones and all that stuff. So I guess it does happen over time, which is a good thing, I suppose. What's the future as we get close to wrapping up here? What's the future for connected factories, do you think? What does the Dave Trail crystal ball show?
I talk to a lot of customers that are Arch customers, and we do a lot of work with EMS companies. In fact, 6 out of the top 10 EMS companies in the world are Arch customers, and we manage thousands of machines for them. And one of the things that I keep on hearing even as I approach more and more OEMs as opposed to EMS companies is, well, we do some production here at our facility, but we do a lot of production at X EMS company. And then you drill down a little bit deeper and you find out that the OEM has actually purchased the equipment that is at this EMS company. And it's their asset, but it's operated by their people under their roof, et cetera. And they want to have more visibility into what's taking place at some of those EMS companies. And there's been a lot over the years as far as being able to take some of these KPIs and dashboarding and things like that and making it shareable from one factory to another within an organization. I think there's going to be a certain degree of transparency that takes place across organizations and across supply chains. And I really think well, initially some people will protest that because they're not necessarily going to want to open their kimono and be able to show some of these low efficiency numbers that we talked about and things like that. But ultimately, I think this visibility and this connectivity, not just of technology, but connectivity of organizations working together, I think is something that we'll see more and more of in the future. And I'm in fact looking forward to that.
As am I. Dave Trail, talking from Hawaii. I wish I was there with you once again, but we'll have to settle for digital technology. I will be there in February at the SMTA PanPack. There's a plug for the SMTA PanPack conference, microelectronics symposium. Thank you very much for being my guest today. You helped me fill my knowledge gap of Industry 4.0. I knew it from a 30,000 foot level. I feel like I'm not quite at ground level yet, but I'm down, at least above the weeds now. So I thank you for filling in some of those gaps for me and making it more than just a buzzword. I appreciate it. And I'll look forward to seeing you, if not before, in Hawaii in February.
Sounds good, Mike. Thanks a lot. Good to talk to you again.
Same here. Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeKonrad.com. That's Konrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.